All right, we've got a help session, 6.6, question number 4. In doing this, we've got to get our bases to be the same. So we'd have base raised to the x is equal to base raised to the y. If these bases are the same, then I can say, hey, x is equal to y, right? That's what we're trying to do. Well, the first one we have 8 to the 3x equals 8 to the, well, that's a power of 1. And in doing that, since our bases are the same, we can say 3x is equal to 1, and then turn around and divide both sides by 3 by solving by x, so x equals 1/3. So A would go with the first one. Okay. Now, let's look at the last one, and then we'll talk about this one. Okay. All right. I got a base of 8 here raised to 3x. I have 64 here. Well, what you have to understand is, can I rewrite 64 as a power of 8? And I can. There's 8 to the 3x. Now I can rewrite 64 as 8 squared. And in doing that, that leaves me with 3x equals 2. Divide both sides by 3. X is equal to 2/3, right? So that means that this one is C. Now, the one that's 8 to the 3x equals negative 8 to the first. Okay, are those bases the same? They're not. And I can't get them to be the same, right? One's positive, one's negative. So therefore, this would be the easiest explanation without having to go into a lot of theoretical is this one would be the no solution. Okay, so there you go. So let's do this. Any questions off of that?
No.
Okay, that all right. Did the no solution one make sense? I mean, that's about as simple as I could put it.
Yeah, I just said because the bases. You said the base had to be the same, right? So
Right.
yeah. So
And see, I could rewrite 64 as a power of 8 squared, right?
right.
Yeah, so, yeah. All right. What else would you like off of 6.6? Any other questions off of that?
Number 10.
Okay. Let me go grab number 10 real quick. All right. So we're looking at number 10 off 6.6. There's a couple ways that you can approach this, okay? But the first thing that you ought to do is you ought to see that e to the 3t is just move it over. Now, what this is going to do is 6 minus 4 is what? 2. So that leaves you 2e to the 3t. Okay, that's the easiest. You're basically, it's like subtracting coefficients on a like term. Okay, now in order to get rid of an e, I need to take the natural log of it. But before I do that, I've got to make sure that it's just e over here. So divide by 2, so I get 3/2 equal to e to the 3t. Now, in doing that, I've got my e isolated. I can take the natural log of both sides. This cancels. Okay, I'm going to bring that up here. So that's going to leave me the natural log of 3/2 equals 3t. And of course, I can divide both sides by 3. So t is equal to the natural log of 3/2 divided by 3. And when you do that, Natural log of 3 divided by 2, enter, divided by 3 gives me 0.1352. Okay, now what we're going to do is we're going to go back over here and check it. So I'm going to pause. It verified that the answer was correct. So there you go. That's the easiest way to do this type of problem. Now, let me do this. Any questions off of that? The biggest thing you got to make sure you understand is when you're working with an E, in order to get rid of it, you have to take the natural log of it. So I got it isolated by itself, right? It canceled. It just left me with everything that was up in the exponent, right? And what you do to one side, you do to the other. So, which gave me this, right? And then I divided both sides by 3, which gave me, I went out to 4 decimals. Okay? All right. Any questions off of that one? Y'all good on that?
Yeah.
All right. Where else you want to go?
Right under it, number 11.
All right. All right. So here we go. This is number 7. Okay. First things first. We're going to use logs to solve this. So we need to get everything over to the right hand side except for what's being raised to a power, right? So the first thing we do is that's negative 7 times 10 to the x plus 2 minus 6 equals negative 18. Well, I'm going to add 6 both sides. So that's negative 7 times 10 raised to x plus 2 equals, well, that's negative 12, right? Now, we're going to divide by negative 7. At this point, that cancels that out, leaves me with 10 to the x plus 2 equals 12 sevenths. Now, this, what we're going to do now is we're basically going to take the log of both sides, okay? We're going to take the log here and the log there, okay? What's going to happen is the properties of logs allow us to take this to the front. So what we're going to have is we're going to have x plus 2 times the log of 10 equals log of 12 sevenths. Okay. Now it looks a little confusing, but just stay with me. I need to solve for x, okay? So the easiest thing to do is just go ahead and divide by 10, log of 10. So I've got x plus 2 equals the log up top of 12 over 7, right? I'll do that a little bit better. Oh, shoot. Let me do it like this. Log of 12 over 7 divided by the log of 10, right? Well, if I want to solve for x, guys, all I have to do is do what? Minus 2. So I would do all of this minus 2. That would be what x equals, right? Because x would be equal to, go down a little bit more, the log, we'll put this in big parentheses, 12 over 7, log of 10, right? Then minus 2. So that's really how that problem would work out. It's easier just to not have to distribute through, just divide this log, because you're solving for excuse me, for x, so it's just tied together by multiplication. So what we do to one side, we can do to the other. But you can solve, let me go back up and I'll show you something. There's no way that I could get 10 raised to something and positive 12 sevenths to be the same base, right? I couldn't have 10 to the x plus 2 equal to 12 over 7. I can't get those to be the same base. Well, if you can't get them to be the same base, the principles in mathematics is of equality is what you do to one side, you do to the other. Then what that does is it allows you to use logs in order to solve it and use properties of logs, the power of a log and stuff like that to do that. So that's what went here, right? So so I isolated basically my whatever base being raised to a power, right? Then I took the log of both sides. And then I brought the power, this power, x plus 2, out to the front. So that's x plus 2 times log of 10. Now I'm solving for x, so I'll just go ahead and divide both sides by log of 10. And then you have this, in which you, of course, can, what color do I have? Kind of separate that there. I'll separate that. If you find this, just subtract 2, you'll have x, right? But you have to do the logs first, being divided, and then minus 2. So that's how that works out. All right, so this is number 12 off of 6.6. So let me make this go back down. So first thing we got to do is we're going to divide both sides by 4. And what that's going to give me is log of 6 raised to the x equal to 2. Do you remember doing this back in the 6.1 section? You're solving for this, right? How do you solve for a log? Instead, use the definition of a log to solve the equation. You change it over into an exponential, right? Backwards, see? So 6 squared is equal to x. So 36 is x. There you go. So it tried to trick you. But anytime the of is an x, that's really what you're going to do. Okay, so don't fall into that trap. So this is number 18. All right, it's not as bad as what you think. You've got natural log of x squared equals natural log of x plus 2, right? Well, guys, how do you get rid of a natural log? You just make it be the power of e. So what happens is these cancel, and what you get is this: x squared is equal to x plus 2. And ladies and gentlemen, you take these things over to the right-hand side. In doing so, you subtract the x, which would give you negative x. You subtract the 2, and it'd give you the negative 2, and that would be set equal to 0, right? You got a quadratic now. Y'all remember how to solve a quadratic? You can do Pythagorean theorem, or you can factor it. Doesn't really, not Pythagorean theorem. Look at me, quadratic formula. Do apologize on that, but you can do this right here. You know, this is a times c, right? And here's your b. So 1 times that's going to give me 1 times negative 2 gives me negative 2. And then this has to be negative 1. So we got to find things that multiply but add here. So the only factors of 2 are 1 and 2. And because it's negative, we need the difference. So yeah, that makes sense. So 2 and 1 here. Which one has to be positive? Which one has to be negative? Well, because that b's negative, the biggest number has to be that. So you've got x minus 2 and x plus 1 equal to 0. So you set them equal to 0. And that's the 0 property. So you add 2 and that's x is equal to 2. You subtract 1 here, so that x is equal to -1. So there you go, 2 and -1. So that's how you do it. You know, it drops, it gives you a quadratic. I just happen to factor it, right? I used the little x, the a times c thing, and you know, that's what we got. So there you go. All right, so here we go. We got log of 7x plus log of 7 to the 4th, right? Now, we could combine those and yeah, I guess that's the easiest. See this right here? And we'll do it both ways just to kind of see what comes out. These are two logs, the same basis, separated by an addition. So that's really log of 7 to the 4x equal to 1. And then what we do is we just do this, the backward C, right? 7 raised to the first equal to 4x, right? And then we just divide both sides by 4. So x is equal to 7/4, right? That's probably the easiest way to do it. But, hey, we can do this thing another way. Let's take log 7 to the x. Let's move uh, this log 7 to the 4th over. If I do that, this is what I get, right? So what I'm going to end up doing is this. I'm going to do 1 minus that log, right? So I'm going to have to, you can do change of base, you know, log of 4 divided by log of 7, right? Log of 4, enter, divided by the log of 7, enter. And what that gives me is this, and I'll just go ahead and 1 minus 0.7124. And of course, I'm going to 4 decimal places, right? But I'm going to do 1 minus that. And what I get is log of 7 to the x is equal to 0.2876. And guys, if we've done this right, and I think we have, we should be able to do this and get 7 to the 0.2876 is equal to the x. So 7 raised to the that, guys, guess what that equals? 1.75 is equal to x. 7/4 last time I checked was 1.75, right? I kind of like the left side over there a little bit easier, but you know, you could do both. You know what I'm saying? You could do either way. I like the left side. It's a little bit, you know, combining them makes it a little bit easier. You know, understand that bases of the logs are the same, so they're separated by addition, so I can put them together by multiplication. Backwards C gave me the green. 7 to the first is just 7. Divide both sides by 4. X is 7/4. Or I could do it this way right here. There's so many ways to do it. It's just plumb wonderful. So, let me see if you got any questions. This. All right, ladies and gentlemen, this was problem number 15 right here. Okay, so just want to make sure y'all know that's problem number 15. All right, so this is number 17. This is very much like what we just worked on the previous problem. We got two logs separated by, instead of an addition, it's separated by subtraction, right? So we can combine this. So we can say log of 3 of x plus 8 over x minus 8 equals 2. Well, all we're going to do is this. So that's going to give me x plus 8 over x plus 2 equals 3 squared. Okay? Now, x plus 8 over x plus 2 equals 9 over 1. We just created a nice little proportion, right? And solve proportions, we do cross multiplying, which means that and then that. So we're going to go 9 times x plus 2 equals 1 times x plus 8 is just x plus 8, right? So we're going to have 9x plus 18 equals x plus 8. And I got all this room right here, and I'm doing it all right there. So I'm going to minus x. I got 8x plus 18 equals 8. I'm going to move this all the way over here. So 8x plus 18 equals 8. Let's see what we got. We're going to minus 18. So 8x equals negative 10. And I'm going to erase some of this right here. I'm going to go that way. Go that way. So I'm going to divide by 8. So x equals negative 5/4, right? So that's what I got when I did my problem. So it created, I mean, yeah, it gave me a fraction. Radicals, just, well, denominator, numerator, and it's got binomials and everything. But hey, it gave me a nice little proportion, which I could do cross multiplying on that. So, okay, I just worked that wrong. You know why I worked that wrong? Because I can't write stuff down. That's x minus, I saw that too and just put it there. So let me go back and let me fix some stuff here. I'm going to cancel that, going to cancel that, going to cancel. All this right here going to have to go away. All that right there is going to have to go away. I know I just made a mistake. Lord help me. Okay, so that's not even x plus, holy jeez Louise. Alright, so here, so that's x minus 8. Alright, so now we're going to come over here. That'll be 9 times x minus 8 equals 1 times x plus 8. Let me do this real quick. Let's go mute. And there. Alright, now I'm going to distribute. And that's going to give me 9x minus 72 equals x plus 8. Minus x, so 8x minus 72 equals 8. Going to add, now the pretty numbers come out. 8x equals 80, ladies and gentlemen, x equals 10. Now that right there looks a whole heap a lot better than what I had previously. So thank y'all for letting me know I made a mistake right there and reworked it. So I took this right here and I took it up here and done the cross multiplying and then worked it straight down. Okay, so there.